Okay, so today I'm going to be showing you how to solve problems involving implicit differentiation. So here we're given the equation of velocity. T cubed plus v cubed equals 6tv, and the vehicle is moving at a constant or uniform velocity in kilometers per second. Find the velocity after 1/2 second. So you can tell that this is in terms of time because we're trying to find velocity, where velocity should be dv over dt. So dv over dt. So we need to find this. Okay, or actually wait, we have to find dv. So we'll write down the given, which is t cubed plus v cubed equals 6dv. Firstly, we have to find the derivative of the whole thing because it's already equated to itself. So we'll just find the derivative. So the derivative of the whole thing, let's break it down to the derivative of each side. So we put a derivative here on the left and on the right. Now we will distribute the derivative symbol. This d can also be dt, by the way. You can write this as d or d over dt because we're solving for dt, but I'm going to be using d on this example first. So using the product rule, our power rule, we will get 3t squared times dt. That's why you can do over dt so that you can just cancel out dt. We're not going to be doing that yet. So we will get plus 3v squared dv equals, here we can separate 6 from tv because it's a constant, and we can just get the derivative of tv. Okay, for tv, that's a product rule, right? They're multiplied by each other. So using the formula d of duv, you can set t as your u and v as your v. So this will become udv or t dv plus v dt. And you don't need to simplify that, or you don't have to fully express the formula as 1 because this is implicit. We're not going to remove the derivation. So it's going to be 6 times t dv plus v dt, and we can distribute 6 on the inside the parentheses. So this is going to be 6t dv plus 6v dt. And we can copy this side. Okay, now that you differentiated or find the derivative of both terms or all terms, we're gonna have to group them in terms of their derivative, or like this, the last term. So as you can see, the ending of 3t squared is dt, 3v squared is dv. Meanwhile, this one, 6t dv and 6v dt. So you can see a pattern here. They all end with the derivative of this one, right? So what we're gonna do is transfer like terms on each side. So we're gonna let v on the right side, so this will become 3v squared dv minus 6t dv. So as you can see, I'm just transferring this guy to here, and then equals we retain this guy, so it's going to be 6v dt, and then transfer this to the other side. So this will become minus 3t squared dt, because when we transfer, this is going to be a negative side on the other side. Okay, now that we have similar terms on the equation, we will factor them out because the common terms of these numbers are dv and dt. So put a parentheses so that we know that we're factoring them out. So this will become 3v squared minus 6t times dv equals, factor the right side as well. So this will become 6v minus 3t squared times dt. Okay, now we're supposed to find dv, right? Because acceleration is dv over dt, whereas the velocity, it should have been ds over dt, but it's said here that the vehicle is moving at a constant or uniform velocity, kilometers per second. So we can say, or we can divide this whole thing by dt, yes, dt. So this will become dv over dt, right, 3v squared minus 6t dv over dt equals 6v minus 3t squared. Okay, now we can set dv over dt to 0 because it's moving constantly. Therefore, if we multiply this with 0, then the whole term, the whole left side is going to get cancelled out or turn into 0, right? So you will be left with 6v minus 3t squared equals 0. Then we can manipulate this to finding for v, right? So this will become 3t squared equals 6v, and then we divide this by 6, so you will get 3t squared over 6, or that's basically t squared over 2 if you simplify it. Okay, then we can substitute t, your second, to 1/2 because it's given in the problem. So that will become 1/2 squared over 2, which will give you 1/8. Let's find the important numbers we can extract from this equation, or this question rather. So it increases at a rate of 200 centimeters per second. That's already our rate, right? So that's the change of dr over dt. Okay. Then our radius, the radius is 5. It's right here. So r should be 5 centimeters. Alright, so now, since it's asking for how fast is the area of the ripple, so that means we are going to be finding for dA over dt. The formula for area, right, is pi r squared. Pi r squared. So let me revert this to the a equals pi r squared first. Right. So first step, of course, you find the derivative of this in terms of dt. So we will get the derivative of the whole thing, d over dt. Okay, now I'm using d over dt for this. So we will get dA over dt is equal to d over dt pi r squared. Okay, now let's focus on the right side, the derivative of pi r squared. Since pi is a constant number because it's 3.14, right? We can set aside it and multiply by the derivative of r squared. Now r squared, you can get that and you can solve for that and get 2r dr. Okay, wait, dr over dt rather, because this is going to be in terms of dt, so dr over dt. So now we have r, which is 5, and dr over dt, and we're trying to find dA over dt. So okay, let me transfer this here. dA over dt is equal to pi times 2r dr over dt. And well, you look at that. We already have all the information we need to find the area or the rate that the area is increasing. So all we have to do is substitute the values. So 2r, this becomes 2 times 5 dr over dt, 2 centimeters per second, right? So this becomes 2 also, and don't forget about pi, equals. So the answer is 20 pi. And let's add square meters, square centimeters per second. So find d theta over dt. Okay, so once again, let's copy the given equation, 4c squared theta t equals theta squared minus t squared. Alright, let's get the derivative of this. And for this, we don't even need to use d over dt because this is in terms of dt already. We have t in the equation, so we will just use d. Okay, so after this, once again, we find the derivative of each side of the equal sign. So the left side, the derivative of 4c squared theta t equals the derivative of theta squared minus t squared. Okay, now for here, we can set aside this. Okay, we can set aside 4c squared, 4c squared. So 4c squared, because 4 is a constant, and if you're gonna have the c squared, then that's gonna be even more confusing. So we're just gonna focus on theta and t because this is technically theta times t. So we find the derivative of theta t here. Now for the right side, we're gonna find the derivative of just this, right? Now this is simple because it's just the power rule. So we will just transfer 2 in the front of theta, and then d theta minus 2t dt, right? Okay, you understand, because this is n u n minus 1 derivative of u. Okay, so now we will find for theta times t. So this will become 4c squared times the derivative of theta t. Let this be your u and let this be your v. So we can say that this is theta dt plus t oops d d theta. equals 2 theta d theta minus, oh, this is minus, okay, 2 t d t. Okay, once again, we will multiply 4c squared with all of these terms inside the parentheses so that it makes our life easier, because if we were to not factor these out, then it would take us longer to do the product rule, which is why we're doing this. But essentially they're the same. So 4c squared theta dt plus 4c squared d dt d d theta equals to theta, oh god, um sorry, 2 theta d theta equal minus, okay, that's minus, okay, 2 d dt. Okay, now we will combine like terms, so I'll put the d theta on the left side and then dt on the right side. So this will become 4c squared 2d theta minus 2 theta d theta, and then equals to minus 2t dt minus 4c squared theta dt. Now we just have to factor these out, so this will become 4c squared d minus 2 theta times d theta equals negative 2t minus 4c squared theta dt. So we're supposed to find d theta over dt. So all we have to do actually is, okay, now that you group them or factored them out, we will just divide the whole thing by dt times 4c squared d minus 2 theta, so that we can, like, it becomes in terms of dt, because we will this will turn into d theta over dt, and then instead of having the 4c squared d minus 2 theta here on the left side, we can automatically have it the denominator of the right side. So this becomes 4c squared d minus 2 theta, then here on top, negative 2t minus 4c squared theta. Okay, so for letter B, number 3, we're gonna find y prime if ln y equals, actually this can be ln parentheses y equals y plus x. Okay, this isn't too much of a hassle, because legit all you have to do is, once again, find the derivative of the whole equation. So since we're not trying to find t here, it's not d over t anymore, so we will use small d, and that will be ln y equals derivative of y plus x. So again, we're just trying to find the derivative of this whole equation. Alright, now step 2, find the derivative of the individual things, So dy, ln y, ln is, ln x is, remember that ln x is 1 over x times derivative of x. So that's essentially the same as this. So we are gonna do 1 over y dy equals, okay, dy plus dx. We're just distributing the d. Okay, we have to make it so that it becomes dy over dx. So let me merge 1 over y times dy into one term so we can understand it better. And then, okay, once again, we will group the terms, the like terms, right? So this becomes dy over y minus dy equals dx. Okay, I don't think I need the equal sign here, but I'm just writing the equal sign for you to understand that it's the next step. Okay, so now that we have this, we can group them, factor them out into dy. So this will become 1 over y minus 1 dy. And since we can't really factor anything on the right side, this will become dx. Okay, so now all we have to do is find dy over dx, because dy, where can I write it? Dy over dx is same as y prime. So again, we're just gonna divide the whole thing by dx. Okay, I'm dividing it by dx over 1 over y minus 1, right? So I can turn this into dy over dx equals 1 over 1 minus y minus 1. Okay, take note of that. Now when you're doing this, this is usually a fraction. When you're simplifying this, I mean, this can become 1 over 1 over y minus 1 over 1. Okay, then we can just cross multiply this out. So this becomes 1 over, so cross multiply this, and this becomes 1 minus y over y. Okay, dy over dx. Then remember that this is in the denominator, so this becomes a over b over c. We can find the reciprocal of this, so we can just multiply it instead of dividing. So this becomes a over 1 times c over b, so which is why it's ac over b. So this becomes a1 is going to be your a, y will become your c, and then 1 minus y will become your b. So this becomes y, or 1 times y over 1 minus y, which is y over 1 minus y. Okay, so for letter C, number 3, I will be explaining this in fewer detail because this is quite long. The solution is going to take a while, so I'll be simplifying my explanation here. So first, okay, let us convert this to something easier to derive. So 4q squared t is fine as it is. However, this one, q squared minus 2t squared to the power of 2, that is quite difficult. That looks to be a binomial, right? You can actually multiply both of these to form a trinomial. So this one times q squared minus t squared, or you can do the shortcut, but I'm not going to do the shortcut because I'm here to explain. Alright, so we are going to multiply each of these terms like the FOIL method, right? This will become 6 to the power of 4 minus 2 t squared q squared, or q squared t squared, it really doesn't matter, plus t to the power of 4. Right, now that we have this, we will differentiate it. So let me write it down here, equals q to the power of 4 minus 2 t squared q squared plus t to the power of 4, and then let us put d here. And we're gonna find the derivative in terms of dt. So we'll just use d because t is already given in the equation or in the solution. So for the left side, we will separate 4 and get d q squared t. And as you can see, that's a product rule, so I know we're gonna do the product rule for that. And then d q4 minus, we're gonna separate 2 and then solve for t squared q squared plus dt4. Okay, so left side first, 4 times product rule, so this will become, let's put a parenthesis so that we know it's different from the 4. It's gonna be q squared, let this be your u and let this be your v, so dt plus t tq, I mean, wait, t to q dq. Okay, and then equals, we can mentally do this, for q cubed dq minus 2 times 2, or another product rule, let t squared be your u and let q squared be your v. So this will still, okay, this will be t squared 2q dq, oops, plus q squared 2t dt plus 4t cubed dt. Okay, here we go. Now let's distribute 4 and 2 on all of these terms. So we can just have this as 4q squared dt plus 8, because we're multiplying 4 and 2 here, 8t cubed dq equals 4q cubed dq minus 2, 4, that's 4, that's negative 4 actually, because there's a 2 here. So this will be negative 4 t squared q dq minus 4q squared t dt plus 4t cubed dt. Okay, now I want to group these terms so that they won't look as confusing as they are now. So let's have dt on the right side, so dt and dt all on the right side, and dq, let's have a different color for dq so we know. Okay, so dq will be on the left side, will be shifted to the left side. So let's start with 8t q dq minus 4q cubed dq plus 4t squared q dq, okay, equals now, because on the right side we're gonna have dt. So it's gonna be, wait, let's keep this one. It's gonna be negative 4q squared t dt plus 4t cubed dt, and then transfer this one to the other side, negative 4q squared dt. Alright, now we're gonna factor them out, and then it's gonna turn into 8tq minus 4q cubed plus 4t squared q times dq equals, okay, negative 4q squared t plus 4t cubed minus 4q squared times dt. And since we're just trying to find dq over dt, all we have to do is divide all of this by dt times 8tq minus 4q cubed plus 4t squared q, so that we can transfer 8tq, this term, into the right side, and it'll become the denominator when we actually divide it, and then dt will also be the denominator on the left side. So dq over dt is going to be negative 4q squared t plus 4t cubed minus 4q squared over 8t q minus 4q cubed plus 4t squared q. Is that correct? And yes, it is. So for the last question, find the slope of the line tangent to the graph of this equation. So we know that the slope of the line tangent to the graph is dy over dx. So here we're not going to use y prime, we're not going to use just d, we have to differentiate in terms of dx. So because it's the slope, right? So we will have d over dx. Okay, let's copy this equation thing. So this is going to be very long, so brace yourselves. 12xy plus 4y minus 5 equals 0. So we're gonna distribute the d over dx sign on all these terms. So that's going to be d over dx x squared plus d over dx y squared minus, here as you can see x and y are both multiplied to each other. That's 12xy. So we can separate 12 from xy and focus on finding the derivative of x and y by using the product rule. And then 4 plus d over dx 4y minus 0, you can automatically say that the derivative of 5 is 0. So basically we're just gonna cancel these out, and it makes life easier. So now we find the derivative of each of these terms that we just laid out. So this becomes 2x dx over dx plus 2y dy over dx minus 12. Then let's put a bracket here, or parentheses, so that we know that we're multiplying this. So this becomes x d, let this be your u and let y be your v, so you're gonna do u dv. So dy over dx plus y dx over dx plus dx 4 dy over dx. Okay, now that you have this equals to 0, by the way, we will cancel out the ones that are cancelable, which is dx over dx. So we can cancel this out, we can cancel this out, and yes, that's pretty much it. That's cancelable. So now let's copy the whole thing. 2x plus 2y dy over dx minus 12x dy over dx minus 12y plus 4 dy over dx. Now we will combine like terms. Let's have the left side the ones with d over dy at the end, and let's have the right side the ones without dy over dx. So this will become 2y dy over dx minus 12x dy over dx minus a plus 4 dy over dx is equal to this, so we transfer it to the other side, so this becomes 12y minus 2x. Okay, now we can group these terms on the left side and factor them out in dy over dx, in terms of dy over dx. So we can just separate dy over dx from each of these terms to get this 12y minus 2x. Okay, now here I also forgot a crucial given in the problem. So we're supposed to find p at point 0, 1. So in a point, the first one, this part, will be your x, and this part will be your y. So we can just substitute in x and y on this one we just made. So we can say 2 times 1 minus 12x, which is 0, plus 4 dy over dx. Okay, I don't have space right now. Equals, because I can't write in here, equals 12 times 1 minus 0, because your x is going to be 0. So here 2 plus 4, that's essentially just 6. 6 dy over dx is equal to 12. Then divide by 6, and your slope is going to be 12 over 6, or simplify to 2. That is the answer for number 4. Let's put a box.